Hello students, these are the important topics for your UT3 papers. The topics are recursive function and example, passing default parameters and reference parameters to functions, then string based output problems, random function based output problems, passing string as parameters to functions, and passing 2D array as parameter to functions. Okay, so we first start with recursion or recursive function. Okay, what do you understand by the term recursion? Now, what exactly is recursion? Recursion is uh, when a function calls itself. It is called, or the function is called recursive function, and this entire thing is known as recursion. Now we try to understand what exactly is recursion. Let's see, we have a function void a, okay, and this a is nothing doing, it's just printing I am a. Now we have another function, say void b, which is calling this function. Okay, so this is a function calling another function. Now if I execute this function in void main, I just call the function b. What will you expect here? The result, this function is calling the function b is calling the function a, and so as a result the output will be I am a. Now let's see, we change a little bit the scenario. Now if it is not calling a but it is calling b, that is itself, so the function b is calling it itself, and this call, as we see, it keeps on, when it reaches here it goes for the b and it calling again, reaching this point, and this is the point of, we call it's a recursive statement. This statement is calling itself, so rather than coming here any output, this will become a infinite loop, infinite execution of or call of statement, call of function p. So we need a way to get out of this. Okay, so mostly in recursive functions what we need are two cases. There are two cases. A recursive function consists of two cases. Okay, so what are the two cases are there? The case one is what we call is the base case. Okay, so there are two cases here, so let's see, we don't write case one, it's a base case. Let's see, the base case is a condition which terminates the execution of recursive function. As you have noted, in case of this function, it's an example of recursive function, but it will keep on executing till it reaches as there is no base case involved here, it's only a recursive statement. So we need a statement or a condition which terminate the execution of the recursive function, so there won't be any more recursion calling of itself, and there will be a recursive case, a statement which calls the function itself. So it calls the function itself. So this is a recursive case. Like this is a recursive statement. So whenever we create a recursive function, we need to take care a condition, or I can say as a statement which terminates the execution of the recursive function, or it takes you out of the recursion, and a recursive case, a statement which calls the function itself. So that is the recursive statement. Okay, recursive statement. Now a very good example of recursive is the function of factorial. Factorial of any number. Okay, let's see factorial of n. Let's see, this is a function fact n is equal to n multiplied by n minus 1 multiplied by n minus 2, and we keep on doing till we reaches 1. Okay, so if it's a factorial of function 5, so it is going to do 5 into 4 into 3 into 2 into 1. Now let's understand how we can do this thing. We can do with the looping statement, but how we can write a function using recursion for a factorial. So the very first thing before we write a function, we have to see what are the we have to see the base case and the recursive case. In case the base case is the one for which we know the solution. So we know a factorial of 1 is 1. Let's see, that's the easiest case, or even 0 you can take, but let's see, it's a factorial of 1 is 1. This is known. But if let's see if somebody is asking what is the factorial of 99, so it is quite difficult for you to immediately tell that what is 99. But yes, you can tell that if somebody tells you factorial of 98, then if you just simply multiply by 99, then you can tell what is the factorial of 99. Okay, so fact of 98 multiplied by 99 will give you the factorial. Now we take a case of n. So how big or small a number is, so here it will be, that means it is n into factorial of n minus 1. So we have got two cases. This case is here is the base case, and if you look at this one, this is our recursive case. So let's write the recursive function. So long fact int n. Now the first is the base case. So when n value is 1, return 1. Otherwise, else you can write it, otherwise it's not required, as return will take you out of the function immediately. So otherwise you need to, it's better we write else return the recursive case here, which is n multiplied by fact n minus 1. Okay, so this is the this is the definition of the recursive function to calculate the factorial of a number. Now this is this statement. Okay, like say this is our base case, and if you look at this one, this is the recursive case. Now we want to execute this function, so it's quite simple. If you want to execute this function, let's see, I want to see the value of fact 5. So if I execute this statement by this, so it's going to give me the output of factorial 5, which is 120. Now let's see how this function has worked. Okay, so this is the working, or we call, I think that the word dry run, okay, or the traceback of the function calls. Now if you look at the uh, function call, the very first time in void main it called the function 5, no, fact5. Now when this fact5 is invoked here, in this case here, so it will stop the execution. Okay, so let's see a little to explain this in a little better way. Let's say this is along factf, and there is another statement here. So the next statement is cout x. So as soon as this statement is executed, this statement execution will wait till the function fact5 return a value. So this cout x statement will not able to execute till this fact5 value is returned. Now you see how it happens. So when the very first time it goes to this long fact, it checks if n is equal to 1, so it will return 1, but this is not the case. So it is going to call this is going to this statement which is saying 5 into n, this is 5 fact n minus 1 4. Now again this function fact4 will not able to return any value as it's a function call, so it will go again, it will call itself with a new value which is 4. Now it goes to this 4, so this time it will be 4 into fact3. Now if we see this is fact3, so it will be 3 into fact2. Now fact2, when fact2 is invoked, so these all are in a waiting state. Fact5 is waiting for fact4, fact4 is waiting for fact3, fact3 is waiting for fact2, and now fact2 will be waiting for fact1. Now we have reached the base case. This is the fact1. Now at this stage, when we reach the fact1, we know the fact1 value. Now we have gone in this order. We were waiting from this fact5 to fact4, then fact3, then fact2. Now we know the result of fact1. So this will now this fact1, when it will go here, so this fact1 is going to return you the value. Okay, so let's see, we write it here for fact1. So n is 1, so this is going to return the value this time 1. Okay, now this value of 1 will be going to here, because now it's the function 2 is waiting, so it has got the value of 1. So it's a 2 into 1. Now this function, okay, I think it's looks better here. Now this is 3, so it's waiting for 2, so it will get the result of 2 into 1, that's 2 here. Okay, so this result. Now this result fact3, fact4 is waiting for this one, so fact4 is waiting, so its fact3 is 4 multiplied by 6. Okay, so now this fact4 result, here fact5 is waiting for fact4 result, so fact4 result will be using 5 into 24, so 5 4, so 25 to 10, so 12, so it's 120. So this is the result of fact5, this is 120. Now this statement now is waiting for the result of fact5, so it gets the result here. X value is now 120. Once this value is reached, So now this statement will be executed and the output will be in this case is 120. So this is one a very common example given in almost every book which is discussing the topic of recursive function. Okay, so this is one. So let's see another one more example. If we want to, which we can do with the recursive function, can be done with the looping methods. As you have already understood, this can be easily done. If I want to do the same thing with the looping method, it would have been a for loop doing the same thing. But recursion is basically a very elegant solution, and in many problems it is not just simply a solution but a necessity to get the results, especially in trees, searching methods, etc. Now let's see another example. Mm, uh, Write a recursive function to find the sum of first n integers. Okay, to be more specific, first n natural numbers. Okay, let's see, the function is sum n. Okay, if n, so if somebody is saying to find the value of uh, 10, n is 10, so it means is 1 plus 2 plus 3 plus 4 dot dot up to 10. So there are ways to do this thing, but if somebody asks you for a bigger number, let's see 100. So in this case, what will be the recursive solution of this one? How can you put one part of this function, a function itself telling the solution of this one? So it can be done something like this. If you know the solution of sum 99, I think if you just add 100 to it, you will get the result. Okay, let's see. If somebody asks you, okay, then tell me what is the sum of 99, so you can say it is 99 plus sum of 98. Okay, so likewise, if we go for a solution of this one, it could be something like this. 90, if the number is n, so what the pattern we see here, it's when it was 100, so it's 100 and plus 99, which is 1 less than 100. So it is very simple, it is n plus sum n minus 1. So here we got our recursive case. Now this 99, how long we can go for till we know the sum for which we know the value of that sum n. So let's see, whichever number which you feel here, 1 2 3, which you think, but let's say the most easiest case is sum of 1 we know is 1. So let this consider to be the base case. So when we write the function, so let's see, this function is int function sum int n. So if the base case n value is equal to 1, then you return 1, else or just otherwise. We don't need a else statement, because if it is not executing, if it's executing, it will not reach this one. Return only one of the returns. If multiple returns are there, it will only execute the statement for which the return statement is true. So it will be n plus sum n minus 1 as we have written. So this is the base case. I want to check the function in main, so let's go. If here, okay, so here is main. I want to check it for the, let's say, take a number for which we can easily find it. Let's say sum of 9. So let's say we take int s is equal to x equal to sum of 5. Okay, and then we are printing the value of x. Okay, so let's see, we do the dry run for this function. Now we go for the dry run for this function. So when this statement, the void, see, whenever we are doing any kind of execution, we always have to see the void main, because the program, the runtime environment always look for the void main as the starting point. So this is a driver function, like in all the languages it is, and it executes one by one. So when we come for sum 5 here, this line, when this is the first line, sum 5, so it will go to this function sum 5. Okay, so sum 5 will, so here the value of n is, so you get the value of n here in this case is equal to 5. So let's see, sum 5, n is equal to 1, which is not true. Here n is 5, so it will go to the statement of 5 plus sum 4. Then sum 4, again we don't know the solution, so sum 4 will invoke again call itself, it go to here sum 4. So here it will be 4 plus sum 3. Sum 3 will be 3 plus sum 2, and sum 2 will be 2 plus sum 1. And now we have reached our base case, which is sum 1. When n is equal to 1, it is going to return the value of 1. Now this sum 1, when it is returned, it goes here, so it will be 2 plus 1. Now this sum 2, okay, this sum 2, it's waiting here, so it will be 3 plus 2 plus 1. And we come to here, it will be 4 plus 3 plus 2 plus 1. And when we come to here, so as you can see, it's not exactly this type, so you can write this as the value return is not say simply 2 plus 1, so it will be basically 3, and this 3 goes here, so it is becoming 6. Now this 6 going here, so 4, it is becoming 10. Now here this 4, 5 plus 10, so this value is 15. Now this value is returned to the function called sum here, so here the value returned is 15, x value is equal to 15. So the output will be, so it prints 15, so the value of x is printed as 15. So you can understand, see, recursive functions are not very difficult if you can see what which is the base case solution and which is the recursive case solution. You can easily convert any function into a recursive function and make it work. So finally I am now discussing one output problem. So let's see, we have given a function and there is a value, and we need to find out what is the value when this particular function is called. Now if you look at this function, it's very easy to understand that this is a recursive function, and in the recursive function it is calling this thing. So when I call this value of fun a and b, that means I'm getting here n1 value is equal to 32 and n2 value is equal to, in this case, is 24. Okay, so let's see if I execute. So if from this line it will go straight to here, weight a's value is copied to n1 and b's value is copied to n2. Now the very first case, so both n1 function n1 and n2, So here I'm writing these values. This is 32 and 24. So you can see n2 is not equal to 0. So n2 is this one. Okay, so this is not equal to 0. So it is calling the function with the value of n2 is now here. So this and so the value of the first parameter, second, this n2 is copied here as the first parameter, and n1 percentage n2. Now if you look at this n1 percentage n2, so 32 divided by 24, so you can easily see is the remainder part. So this is the 8. So 8 is the remainder. Okay, now we come to here. This is again a recursive call, so it's the function called 24 comma 8. Now again n2 is this value now, and this is not equal to 0, so the function will call now now this value 8 will be copied here, and this n1 percentage n2, that means 24. See, you always have to consider the first one as n1 and n2, though in this step we are copying the value of n2, but thereafter when it going for the next function call, it is becoming n1. Okay, so it's 8 here, and as we know 24 is fully divisible by 8, so remainder is 0. Now we come to the function call with 8 and 0. Now with 8 and 0, you see n2 is not equal to 0, it is false. N2 is equal to 0, so it will return now a value n1, which is not a recursive call. So the n1 value is return n1, so it is returning, the function is returning the value of 8 here. Okay, n1, which is 8 here. Now if you see this particular function here, function n180 is waiting. This function has called this one, so it has received a value of 8 here. Okay, now it is just waiting for this function to return a value, so it has returned a value of this to 8. So function 8 to 24 8 gets the value 8. Now this 24 8, this function call, this 24 32 24 is waiting for this, so it will return this function value is 8, so this is equal to 8, so it will come here. And finally, so this 8 which is waiting here for 32 24, still it, see, there is no other calculation is there, so simply the value will be, each one is waiting for the value, so each one will get the value till it reaches the first call of the function. So here it gets the value 8, and then this value is returned to the function which is waiting here. So here the output will be 8. So you see, this is so you can just need to follow the steps like the way I have shown you, so you can solve any recursive function program. You can write it, and even you can solve the output of the recursive function. So as the name I have given, it's fun, but it's basically a HCF function. So this is an example of HCF function, so it can work for any of HCF of any two numbers. You can find it out by using this function. So here we come to the end of the topic of recursion. Our next topic is default parameters and reference parameters to a function. So we deal one by one. Let's see, what do we mean by default parameters. Okay, so the word default parameters is slightly giving us some idea, some parameters which are default, but it's not the parameters, but the values of the parameters are default. Okay, so when we assign default values to the parameters, declared in the header line of the function, we call those parameters as default parameters. Okay, now these default parameters are very helpful if when we call function without values for the parameters declared or rather required declared, then default values are considered for the parameters. Okay, so let's see an example to understand this. So we have a function called print, and here we give a print function with default parameter. Let's see, ch is equal to asterisk, and int is n equal to 5. Now this is a very simple function where int I equal to 1, I less than equal to n, I plus plus, and we are going to just write here cout ch. Okay, and let's see one cout new handle, and let's see a new line character, and this is the function call. Now this particular function, this parameter ch, these are the default values for the parent. So this is the function with default parameters, and we need to understand there's a restriction here that if you assign a parameter to the first one, then you have to, all the successive parameters are to be assigned values. You cannot have a function with something like this, you are giving one here and rest are not given, or just in the middle one is not given. Okay, so we're coming to, so what is, like, if I call this function without any value, okay, normally if it is simply written as ch and int n, it would be a error showing you incorrect prototype, but in this case there won't be such error. Rather here your output will be I think you have already guessed, there will be 5 star, because as there is no value, the ch value is considered to be this asterisk symbol, and n value is 5. So and I is equal to 1 to 5. So for every value of I from 1 to 5, 5 times 5 stars are printed. Okay, 1 2 3 4 5, this is done. Now for example, you give only one parameter, let's say $. Now as the second parameter is not present, but now you have given the first parameter, so it will not assume the default value of ch as asterisk. So the default, this will be, now the ch value is $, and n value is 5. So here it is going to print the $5 times. Now we are taking this time, let's see, it's a hash, and I now give the value. So now you see, so as you see in this case, ch value star and n is 5. This was ch is $, and remain 5. Now this case your output will be, what will be the output? I equal to 1, n is 7. Now ch value also we have provided, so it is going to print hash 7 times. So this is how default parameter works. So it is helping sometimes if we don't provide the values, so the function will not, it will take the default parameters, default values, and it will give you the result, the default result which will be calculated by the function. Now the next one is reference parameters. Many languages, so before that we try to understand what are references. Basically references are nothing but they are the addresses of a variable. So when we pass the address of a variable, okay, so if the parameter is a reference parameter, then it is going to store the address of a variable. So we cannot pass in that case a constant value. We cannot invoke a function with a constant value. So reference parameters, so those parameters or these parameters hold the address of variable passed as parameter time of parameter hold the address of variable passed as parameter, or passed as actual parameter. Okay, so are the term formal parameters. So these are formal parameter which hold the address of variables passed as actual parameters. Okay, so example, let's see, is we have a very simple example. Let's see, void change, and here we are passing ampersand x as a reference parameter. So how to identify it's a reference parameter? When we have a ampersand symbol. So let's see, what we do is x plus equal to 5, so we are adding 5 to it, and then we are coming to void main, and here, as I said, we need a variable. So let's see, variable is 10. We call the function the value of change a, and then cout a. Now when we pass this variable, it goes to the function, it calls the function change, and the address of a and address this variable x and a both point to the same memory location. Okay, so both is holding the value, both is pointing to memory location which is holding the value 10. So now when we do x equal to x plus 5, so its value, that memory location value will be changed. So we are both pointing, it's like both are having the keys for that memory location, so that house, so both can open it. So whatever changes you doing in that particular location, it will be reflected, we both can find. So here x equal to 5, x plus equal to 5, so 10 plus 5 is 15, so here the output will be 15. Okay, so you can see the reference parameters are very simple. Let's see, to make the program more like the very common question, which is the what is the difference between call by value and call by reference. So let's see, there is another parameter y, and we try to do the same thing with y. We try to add 5, and let's see here now, b is equal to 10, and now we pass the value of b. Now if I try to print the value of b here, I will not see the change. So the value of b, which I passed as 10 here, but there won't be any change, and if the output will be for b, the value of b will remain same as 10. Okay, so this is also you can try it for as an example of call by value, call by reference. So this is how the reference parameters means at the time of invocation. You see, when we are invoking it, it is seen. The only restriction is there if I try to do something like this, 10 10, so there will be an error. L value required is required. This, the meaning is that the first parameter needs to be a variable. It can't be a constant. Okay, so it's a memory location. So it is a, so until unless you're not giving a memory location, it will ask for it, so you will get an error. So it must be a variable, not a constant. So this is the very important thing which you need to understand regarding the reference parameter. Now let's do some output based questions combining both the topics of default parameter and reference parameters. Okay, before we move further with the output, there's one more thing, is that arrays are passed by reference. Okay, so by default they are passed by reference method. Okay, so what do we mean? Like void change, let's say this, make another function with passing in a array, and you are doing a very simple for loop. I equal to 0, I less than n, I plus plus, and you are doing x I multiplied equal to 2, and we are coming here and we are going to void main, and here we are writing int arr is equal to, let's say it's 1 comma 2 comma 3 comma 4 comma 5. Okay, so semicolon, and then we are coming to the function of change, and we are calling this change as arr comma 5, and we come to, let's say, copy this for loop so that it is easier. So we make it 5 here, and this is arr. So you will see here output of this question will be, output will be 2 comma 4 comma 6 comma 8 comma 10. Okay, so this is a one example. You see, we don't require to pass the function by ampersand. Array name itself refer to the address. So this is an example, arrays are passed by reference. So in the next video I'm going to explain some more output programs based using the default parameters and reference parameter. So that's it for this lecture. Let's move in the next lecture. I'm going to discuss more with some more example. Thank you very much.